Right behind that, though, is Tag's slope method. And this is the method that I generally point people to because intersecting curves is very comprehensive. And it's a wonderful test procedure. And you're right, exactly right. You need a spreadsheet for this one. You are essentially performing multiple fall potential measurements. At the end of it, you should have somewhere between 30 and 40 or more measurements that were actually taken if you do it to the true definition of intersecting curves. And they're all fall potential like measurements. Slope is going to simplify this step even further. And we have a really, really great calculator that we developed on our website, as well as you will find all the instructions in IEEE 81 on how to perform slope. Slope is specifically purposely designed to test large, horizontally laid electrodes, like a substation ground grid, where I'm limited on space or for practicality. Here we're limited, or our distance is only 2 to 3 times the longest diagonal, and we're going to perform 3 measurements. Now they're somewhat arbitrary. We just need to establish a slope coefficient. Everybody remembers that from like pre-algebra or algebra 1. Rise over run, right? We're going to get a slope coefficient. We're going to check it in a chart, or we can use the calculator to do this as well too. The chart's going to give us a decimal multiplier for the distances that we've already established. So our H was out at, let's say 500 feet. It's going to say, go ahead and establish your S probe, your measurement probe at, let's say 71% of that distance to H. We're going to take another measurement. That's going to be representative of the resistance to ground of this electrode system. We'll repeat it. We'll do this multiple times, ideally not at 180 degrees. So we're not going to test to the south and then go test to the north. We're going to test to the south and then the southeast and then maybe the east or west or something like that as well too. And we should see numbers that are in agreement. I've seen this test procedure. I've not only mocked it up myself on just a small set of electrodes to compare it to fall potential. I've also seen it against fall potential in a very large scenario on a substation. The values are incredibly similar. And we know this because we have a ton of test data, not just me doing, it's an N of one, a couple samples. I wouldn't rely just on that. We know that this is reliable because it produces reliable results, consistently throughout different types of measurements. It'll also error itself out essentially because the math won't work out. We will end up with, a negative value in many cases, where we're not far enough out there. So we're able to test inside those spheres, but to a limited degree. When we think about it from a or an electrical perspective, of the geometry. So definitely consider that test procedure.
Are you seeing that being employed more often in the field now, or is it something that's where did you find out about it? I guess would be because that's a new one to me on the text.
Yeah, so IEEE 81 specifically is where it not where it originates. GF Tag was a engineer and PhD professor in England, I believe, in the UK. He wrote the paper on the slope method in the 60s, if I recall correctly, and it has been repeated. The method is found in various documents throughout, though. Tend to get a lot of pushback on it. Tend to get I don't know if my customer will take that. And I think that's where, because it is in an IEEE standard, we have a little bit more ground to stand on.
Yep.
But I think, I'm sure Tom will agree with me, I think the best way to represent this, or any test procedure, no matter what it is repetitive values.
Yep.
Right?
Makes sense.
I do it, I get a value, I prove that value by repeating the measurement and constricting the variables or the change in variables to just one. Here, it is going to be the direction in which I test, but I could also constrict that change to distance.
Yep.
Right? So if I tested at 500 feet, maybe I can test at 600 feet, or I bring it into 420 feet, for instance. I wouldn't change 2 variables in that case. I wouldn't change direction and distance if I can control that. I would say another thing that's very true about ground resistance testing, unique. Every scenario is very different than the next, right?
That's true.
I don't always get the opportunity of having my ground system installed in a location where I have exactly the right distance to test for my H electrode to be placed out at 100 feet or whatever it may be. I'm going to run into scenarios where the test is going to be very different because of the spacing requirements.
Transmission line towers, all kinds of stuff.
Exactly, right? So it's not testing the breaker. Obviously you're going to run into some different variances location to location when you're doing breaker testing. However, it's a breaker, right? There's only so many variables that can change versus a ground system, which I am very reliant on conditions in which I have no control over.
Yeah, and to Gregg's point, there are many other methods of calculating ground. What we're really talking about is our resistance to Earth with these methods, right?
Yep.
That's what we're trying to calculate. And so whether you're using follow potential, you're using intersecting curves, which is a bunch of follow potential tests that you plot over each other. That's all it is, right?
Right.
Or you're doing the slope method, the delta star method. There's a lot of different methods that are out there. What ultimately matters, and Gregg kind of alluded to this earlier, is IEEE is going to reference all this. It's going to give you the basic foundation for what you need to do. It's not going to hold your hand through it at all. You've got to do your research, right? But at the end of the day, it's the customer who's paying your bills. So if they don't accept that as a test method, good Lord, you better make sure of that one first. So that's one of my recommendations is have that conversation first with your customer. Hey, look, we can't do that follow potential at 3,000 feet. It's just not. I don't have the wire, and a lot of testing companies don't carry that in their back pocket. So we can alternate this test. Here's another one from IEEE. I mean, we are the SMEs. We're the subject matter experts, right? They come to us anyways. So if you go ahead and you give them this information, hopefully they're like, you know what, that sounds good. It's in IEEE. They'll run it by their engineer. He'll say, yeah, it's in IEEE. Of course it's okay, right? And then usually you're okay. You might have to explain yourself a little bit, so don't just totally let the IEEE carry you. You might actually have to know what you're talking about once in a while.
Yeah, believe it or not.